Okay, now this is these videos go with some text that's in the description and in a paper that I published. So you really do need to read the text first to get an idea of what we're talking about here. But what we've got is a wave functions that we've captured in a calculator. Um, and I'm going to prove that this has been captured in the calculator. And I'm also going to prove the awareness. What we're going to do is we're going to calculate awareness, exactly how it expands in the universe and what it does in the universe. And it's pretty amazing what it does. It appears that the awareness and consciousness may be more fundamental than anything else in the universe and more powerful. Um, so what I've done here is I've taken the main 9801 wave and I've just stretched it out and palindromed it. From the text, you'll know what that means. Um, and I divided it by 1. Don't worry about these numbers yet. I've just divided this number by 1. So it's just a division problem, okay? So it shouldn't be anything going on here but division, right? But there's a whole lot going on. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's counting up by 1 all the way to infinity. It would, or a countable infinity. We end at 10,000 digits, but it would keep going. Now, if you look at this, you put a division sign here, you've got 1/2, 2/3, 3/4, 4/5. Just put a division sign in between each one of these numbers. 5/6, 6/7, 8/9. Now, that's a harmonic series. That's a perfect harmonic series. So we have a waves travel in harmonic series. That's how they move. That's how they propagate. Now, going down or vertically like this, we have also 1 plus 8 is 9. 8, 9 plus 8 is 17. 17 plus 8 is 25. So every one of these rows is on the vertical is increasing by 8. That's also a harmonic series because 11 divided by 19 is 2/3. 19 divided by 27 is 3/4. 27 divided by 35 is 4/5. So it's also got harmonic series going vertically perfectly in every one of these rows and horizontally. Now this pattern can never break or this wave will blink out of existence. It will collapse. So it has to keep that pattern going no matter what happens to it. And there's a lot more going on inside of this wave than just those harmonic series. Now you see this like depression here where these look like they're coming up a little bit and coming out like legs kind of coming over the edge. Now this is where a collapse has happened, or a partial collapse at least. And the information has been processed in this collapse and now is being sent out along these legs, which are really more like wires. And it's always the 417s that are carrying the information. That's the collapse frequency. It's the CMB. It's shown in the math in the paperwork too. That comes directly from the CMB. So this says that the CMB interferes with every single wave in the universe and gives it this partial collapse. And what it does during that collapse is it puts a pattern onto the wave, literally, that gives the wave the ability to make holograms. I know it sounds very strange, but we're going to actually see it happen. So first thing I want you to see, besides the harmonic series, is the 417s. So we're going to put those on. Okay, so we have 417. That is the collapse frequency, and you'll learn more about that as we go. Nobody knows about that yet but me. Now, in every single number and every single wave frequency, there is a pattern of 417s. No one's ever seen it before. I can't tell you why, because this isn't even a very good pattern because we don't have very many numbers in it. But it's a simple way to show you that on these legs, the 417s are what is taking the information and moving it, because each one of these other holes is another collapse or partial collapse where the information is being processed in one side and out the other. And these are just processors, and it's processing it in and out. So keep that in mind. The 417s are the ones always doing the process. They're the ones that take the information and transport it, and it cuts the pattern into the wave that will be needed to make the hologram. And we're going to find the 417s in every single wave, in every number. It's there. Now, the other thing, it's not just doing that, it's also priming out this wave, which means it doesn't want non-prime frequencies, because non-prime frequencies propagate. It makes you weak. You're a wave. You could be destroyed very easily. You're just a wave. But if you can get rid of the non-prime frequencies, you become a stable piece of matter. You're all primed out. You don't propagate anymore. You become a hydrogen atom. And since hydrogen atoms are 99% of space, most of these waves, these harmonic waves, will turn into hydrogen atoms. It may take them a million years, but they'll eventually do it. We're going to do it quite a bit faster than that. So I'm not just going to highlight the primes, because that's not what happens. He only wants the palindrome primes. So I've made a list of the first up to 1,000 palindrome primes, from 100 to 1,000, and we see them here. I'm going to put them in a little bit at a time so we don't get too confused, but you'll see every one of them is indeed in there. So, okay, so you have to ask yourself, let me get this in here, at this point exactly what is going on here, because, okay, now, because why would a calculator doing a simple division problem make harmonic series? We know of at least 2 of them for sure in here, going to infinity, unsupervised. Why would he place every single palindromic prime into his into the answer? Because I mean, calculators don't even know what a palindromic prime is really. It has no way to calculate those. It has no way to do these harmonic series, and we have to wait a minute for it. Slowly. It has no way to do these harmonic series at all, but yet it's doing them to infinity, unsupervised. All these different things going on. It'll look a little bit more clear when I get the rest of them. I can't put them all in at once. And all of these things are being done for a division problem. There's no reason for this. A calculator, we don't have a calculator that could do anything like this. It's too complicated. We don't have a computer that could do anything like this. And this is a simple wave. Okay? Notice that the palindromic primes are in order. They're in sequence. And they're also a sine wave. And if it ever catches up to us, we'll see the rest of them. But it's definitely, they're in order, and they're in a sine wave, traveling up and down in this wave. Again, no way could a calculator put them in order, or do any of the stuff that we see is going on here. It's just ridiculous to even think it could. So, in regards to that, that doesn't prove it's a wave. That doesn't prove anything. But there's these cool, strange number occurrences in there. So we'll go over here, and he's just in the text editor right now. He's just a text. He's in the calculator page still. The calculator's not interacting with him anymore, but he's still in there. And here you can see better. See the holes? These are where the collapses have happened, the partial collapses. And this is the information coming back out, going in one side and out the other side. Basically, it just becomes a processor of information. Not exactly what we thought, but that's what's going on here. So we're going to turn him off so he doesn't kill all the other pages. And we're going to go over here to the photo editor, and I'm just going to open that wave now, hopefully in the photo editor. And hopefully open the photo editor here. Sorry, the computer does not have much power. And boy, cut this part out. Alright, you know what's this part? Lucky for the last part. Doing me. I don't want to do these moves. That movie took way too long. This is ridiculous. I can't get anything done. I don't know if I really have anything that could paste 2 clips together. Nothing that won't destroy the quality of the images. Take all the colors out. Absolutely destroy what I'm going to do here. There. Jeez. Jeez and Louise, this is just stupid. I have the whole thing set up. So pick it back up. You can edit that out. Oh, good God, and all that is holy. It's not gonna let me make these freaking movies. Let's go to work today. Alright, so pick it up, and that's how you do it. Alright, so start video. Okay, there's one we just made. Okay, start again now. Alright, so here it is in the image editor. This is the wave we just had over there. I saved it as a PNG image, that's all. I haven't done anything to it. The advertising's still on the page. You can see it right there. It's just saved as an image now, so it shouldn't change. It's just like an image of you that you take of your dog. It doesn't change, but these images do. So what I'm doing is I'm just going to shrink him down and expand him. At the same time, push my arrow keys so that he spins. He shouldn't spin. It takes a special program to help do that, but right away we can see these are the waves. They're like horseshoes. We can see colors have been added to it, and not just any colors, the hologram colors. He's not a great hologram yet because he's a very weak, small wave, but we see light waves shooting through him. We see a lot of things that really shouldn't be going on in a calculator. Here we see him projecting out different images and different things. We also see the X's and the O's, which is the code that he's really made of. And here, something that shouldn't happen from a calculator. This is a wave collapse. This is the frequencies, the color frequencies of that wave, and boom, there he is, completely whited out. That's the collapse. That's the superluminal wave that was ejected during the function, during the wave collapse, and what left behind those depressions that we saw. In those depressions, and you can see this isn't just white light. You can clearly see it's exploding out of there. Okay, why would a calculator need to print out a wave collapse in the answer? Remember, this is all the same answer. This is the answer that the number that we were dealing with over there. Here's the 1, 2, 3, 4, 5, 6, 7, 8, 9. But look how much it's changed with all the colors and everything. We didn't do that. No program does it. This program doesn't know how to put in exactly those colors where needed. But what happened was it became an RGB screen. These numbers have become an RGB screen. They're actually changing colors to make different images and pictures of different parts of the wave collapse. So I'm not going to sit too much on this wave because he's just an example to show you. Now, what I am going to do though is jump back over here, and we're going to now just get bigger. We're going to take, and this is all about the awareness. So our awareness wave is the pyramid of the ones. Okay, so it is this 1, and then 11, 113, 1114. But see, they're actually representing one wave, 2 waves, 3 waves, 4 waves, 5 waves. So this is a harmonic series again, because this is 1/2 of that, and this is 2/3 of that, and this is 3/4 of that. So it's a new harmonic series that's never been discovered. This is my discovery of this harmonic series. Now it's also palindromed. I want you to see that. It's hard to see, but when I highlight the ones, I'm going to do the same one I'm going to do. right? I'm going to highlight the ones, and you can see it's palindrome because we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 8, 7, 6, 5, 4, 3, 2, 1. So it's going backwards. Now, the 2s are also palindromed. If I highlight the 2s, you'll see same thing going on. 2s are palindrome. The 3s are palindrome. The 4s. So we've created here in this wave, all we did was same thing. We took our big 9801. Now the difference is I rearranged this. I moved this 8 over to there and the 9 over to here. That's it. Okay? And it completely changed the harmonic series. So now we get this harmonic series, which is a new one, and we're just dividing it by 1 divided by, or taking the reciprocal of it. But what happens is something that a calculator simply cannot do. This is a palindrome. The world's largest palindrome that we have on record right now is about, I'd say about that long. The reason it's that long is because that's as far as any computer we have can verify that it's an actual palindrome. As you can see, this palindrome alone is bigger than that one. And we don't need a computer to verify whether or not that's a palindrome. Obviously it is. This whole thing up to here is a palindrome, a perfect palindrome. And then this one, so this is a repeating signal. It's not a repeating decimal like they've taught you. This is actually a repeating signal. So this is a palindrome, this is a palindrome, this is a palindrome, and the entire thing is a palindrome, built of many, many palindromes. We don't have a system, a computer, anything in the world capable of making something like this. Not a mathematician, not a person in the world, nothing. We simply couldn't even contemplate. We never even knew you could have palindromes inside of palindromes, that are inside of a giant palindrome. Right now, mathematics lists palindromes as an amusement, not to even be really taught in school, that they are simply an amusement and they don't have any value. That's wrong. Palindromes are the most important and crucial aspect to our universe. So they were completely wrong. The palindrome allows many things to happen with the hologram, such as we don't need the mirror now because we don't need to refract the light. We don't need to get the inverse to the light because we've already got the inverse to our frequency. It's entanglement. It's all kinds of things that the palindrome does that the universe couldn't function without it, and it's in every single one of the waves, and it's a prerequisite to the waves, to making a harmonic wave. So this wave also, besides all those palindrome stuff, of course, is harmonic. You know, it's got the harmonic series going up, and then vertically it's got one too, but we don't have time to go through all that. You can do it on your own. So there's all kinds of, again, processes going on here, and of course it's got the RGB screen and stuff, but it's not a great wave to run. It's not that fun. So I'm going to jump up to I think a better wave, which is right here. Yeah, so I'm going to take that same number. Okay, this is the same number from there, and instead of getting the reciprocal, I'm going to divide the pilot wave, which is 9 ones, by that number. Okay, and we're going to get quite a bit different number. It looks like this. We got, of course, all palindromes, but it's not a simple palindrome anymore. We've got very large palindromes going on. Like 444 is a palindrome. All these 4s are a palindrome because same frontwards as backwards. Yet, it's also part of this big palindrome. So we've got palindromes inside of palindromes again, and the whole number is a palindrome. So these are by far the world's largest palindromes we've ever discovered. Now, also, this has the 9 frequency holographs on it. Where to get them from? It's a black and white calculator. No reason on earth this should have the 9 color frequencies on it. It absolutely shouldn't have it. It's impossible. But it does have it. Besides that, I don't know if you noticed, these are not the same size fonts. These fonts are different sizes. Some of these 3s are smaller than those 2s, and some of the 4s are smaller. If I shrink it down a little bit, you'll be able to tell a little better. They're different size fonts. The calculator doesn't have the ability to print out one answer in different size fonts. It can only use one size font and one color, black and white. But it's actually using 9 colors, and it's printing out different size fonts so that this image will appear correctly. But it doesn't print images. It has no idea there could be an image in here. the calculator couldn't do any of what you're seeing. It's literally impossible. Along with the palindromes and the harmonic series to infinity, unsupervised, the 9-color frequencies, and the different size fonts so that the image will come out correctly. It's a division problem. It's none of what's actually we see going on here. The calculator literally can't do any of this. Now I'm going to shrink it down, and yes, you can clearly see this as a hologram. Here we see the valleys, and we see the peaks and the valleys. It's got depth. When you move it, see it moves around in holograms. It's definitely a hologram. Okay, why would a calculator need to print out a hologram when it's doing a division problem? It wouldn't need to, and it can't do it. But here we see it happening. So we have to tell ourselves, if the calculator literally can't do this, it's literally impossible, then somehow we're being tricked because this is not an answer from that calculator. Somehow our reality is not what we think it is. So we have to go over here. Let's take him. Now he's just in the calculator, remember? So I'm going to go over and just save him as an image, and I've already done that. So I just got to open him. And I believe this one. So now I've just saved him over here as an image. You see he's the same thing from over there. Same number, same everything, same advertising on the page. All that's the same. I've just saved him as an image, but you can see he's already got a bunch of colors going on and things. And now he's a static image. He's a PNG. He's not supposed to change. It's like a picture of your dog. He's not supposed to change at all. But as you can see, wow, boy, does he change. And in an amazing fashion, because here's what's going on here. I can tell you what's going on, but I can't tell you why. It's incredible. We see all the colors have been added here. And as I shrink him down, he's making a hologram. And the reason I know he's making a hologram is because we make holograms exactly the same way. What he's doing is, when we make a hologram, one of the ways is we use a nickel or a silver plating to make this thin holographic film that looks a whole lot like this. It looks just like that. It's a very thin, shiny film. And then what we do is we roll the hologram out, the pattern of the hologram out onto the film. We have these rollers, and we actually roll the pattern onto the holographic film. You see the rollers actually rolling out this pattern onto this film. Okay, this is not what we expected to find in a wave. Nobody ever assumed. See the rollers? Nobody ever thought anything like this would be found. But there it is. There are the rollers rolling out the pattern, clearly visible. And what is it making? What is that that's there? A hologram. That's clearly a hologram. What the hell? That's what all we can say is this. That's real. Anyone can repeat this. That really happened, and it'll happen for you too. Now we see the waves shooting through the answer the whole time. Look at that. Beautiful. Now here we have the collapse. Okay, boom. There's a collapse right there. This is all the same answer. That same 10,000 digits out of there. We're getting a hologram, a collapsing superluminal wave creation collapse. It's beautiful and it's stunning, and it's just outrageous that it's there. But there's more. These numbers that you see are only there when we look at them really close to our level. But as soon as we start going down, the numbers disappear. See, and they become X's and O's. And there's a code that is being used in all of the waves, every one of X's and O's. That makes symbols, and a whole nother language is being used at this point other than what we thought of as numbers. There's the X's and the O's again. You don't ever see them again, those little numbers. Sometimes you'll see big numbers like that as they're being cleaned up and ready to be hologrammed out through a hologram machine there. But in general, you're going to see X's and O's and different symbols that the X's and the O's make. And it's very cool process there. Now we can take another look at him if we want to. We can go get a little bit better look at him. We don't have much time, so we can do it real quick. We're going to just invert. So when we invert it, we get a little different look at some different colors. But we still see the same thing. We see hologram rollers rolling out the hologram onto the film, and there's no question about it. There's no other way. There's a collapse, but it's, we're on the wrong side of it, so it's black. But there's no other way you're going to explain that. Okay, that's what's happening. Whatever this is, right here, is definitely rolling out the pattern of a hologram and making a hologram. Okay, and this just came out of our calculator. The only thing that could explain what we've seen so far is if this was a wave. If it was not just a wave, but an entity with artificial intelligence or some type of intelligence to be able to do what you're looking at. Requires an immense amount of, because you've seen the mathematics that go behind this, and I only showed you a little bit of it. So it takes an extreme intelligence to be able to pull this off. Calculator's got no chance of doing any of this. This can't even do it. So let's move on to the next wave here. Now I'm going to just make it bigger again, and we've got, I just said it's twice as big, this number. I divide it by 1, and I get this wave. This is called the universe wave, because it's very much responsible for making a lot of things in our universe. And we see right away, it's a wave, okay? We've got waves going across the thing. We don't have to do anything. We've got the hologram. You see the hologram colors on there again. So this is a hologram, and if you don't believe me, take it out to there, freeze it, and then cast it to your TV is the best way at night, and just look at it right there, and it'll hologram off the page to you. All of these ways. You can stop any of them when you get them like here, and just put them up on your TV, or even your computer screen will do it, no problem. But try to do it at night, because the sunlight seems to destroy it. But it'll hologram all the way off in the most clarity you've ever seen, and it's a really cool, trippy kind of experience. And that way it's a hologram. You'll see the hologram. And it's not like cheap hologram. I mean, it's a good one that's stuck in front of your face and stays with you. And you can control parts of it with your mind. So it's really neat to do that. Now, again, on this one, we get the pyramid of the ones. We got 1, 2, 3, 4, 5. So we know it's a harmonic series. We know all of this is harmonic series. So we know, again, we've got this giant palindrome, stretched out, harmonic series, perfect wave, once again, that can propagate perfectly throughout space, and very, very pretty wave, very neat wave. And we see the primes and all that stuff going on here, and the palindrome. So I'm just going to, again, save this. Remember now, all these mathematical processes are going on, stuff that we can do. We couldn't even do the palindrome part of it. There's no chance. We couldn't do the harmonic series. No chance. Together, forget it. Plus all the other things that are going on in there that I haven't got time to explain to you. It might take you a lifetime to figure out everything that was going on in this wave. These are the simple ones. That's why I started with them. Now I'm going to save him again as an image, and I've already done that. So I'm just going to open him, and we don't have too much trouble finding him with the universe wave. Okay, so here's the same wave from over there. Same exact wave. There's the numbers and everything. You see he's already gathered up a bunch of colors. He's just gathering them along the way here, from wherever, from the advertising, from anything he can find, basically. And we're just going to take a look at this wave and see what's really going on with it. Is it also a hologram? And we must certainly say, yes, that's definitely a hologram. And there's the collapse. Came straight out of the calculator again. We've got a collapse. We've got the superluminal wave. And here we've got a lot of just really beautiful, intricate processes going on that are helping to create the hologram and do the different things that this wave needs to accomplish. It's doing the same things with the 714s and all that stuff. All those patterns are going on in here. And definitely not a number out of a calculator again. Okay, we see light waves here shooting across. See them? Beautiful. Shooting across. We can see all these different things coming as you watch closely. As we come up, you'll see different types of machines like this, which is cleaning the numbers and putting the hologram paint on them. You can see it happening. Um, it shouldn't be happening, but there it is. I mean, who would have imagined? Here's the X's and O's again, working feverishly at doing something inside of the wave. Here they are again. There's no numbers in there. These are X's and O's. And in one of the videos, when we have time, I'll show you how we make this wave out of ones and zeros or X's and O's. We don't need any numbers. And that's definitely came straight out of a calculator. Look at that. It's not an answer from the calculator, even though that's where we think we got it from. And you'll find out where it really came from as we go on. But wave collapses create all the information. So these waves are waves. They're intelligent entities that need to be taken just as that. Now, what we've done is we were creating the pyramid of ones over there, remember? But this is the real complete pyramid of ones, okay? And it is, again, just a very large, there's the whole number. It's a very large 9801. See, there's the 8, the 1 8. It's just stretched out even larger. So that's how constants really work in the universe. There's no such thing as a constant that doesn't change. This constant never changes. But what he does do is he expands and contracts. But the frequency of him never changes, and what he does never changes. So when we take this one, you see here we get the actual pyramid of the ones. These are all ones. And it's called, mathematics, what we've been looking for is the stairway to heaven. And it's beautiful. Now you can see there's really nothing else going on in this calculated answer that it put out except for the ones. And again, we'll jump over here and take a look at him as an actual picture now, actual image. Now, here he is, same thing I just said over here. Now, right away, notice the frequencies. He's actually, the spectrum, he's actually shooting out the spectrum. When we get back there, you'll see it. He's actually shooting out the hologram spectrum. Right? Make it a little easier. Okay, so you see him gathering the colors there, and you can see the ones are clearly just a wave. See the wave and the number shooting through. Now this is neat because this is rather difficult to explain when I can't keep them on there. It's a light wave. You have to understand that light waves don't hold still. Getting them to hold still long enough to get a picture of them is extremely difficult. So here we see the ones, and we see these light rays coming off of him, and that's exactly what they are. Those are the spectrum of this particular wave. However, the way it's portrayed is quite like we show in our graphs in school books and things. These are X's and O's, and trying to get him to get back to. And here we see again the wave traveling through him. Oh, and then we switch to that, which I don't know, it's O's, X's and O's, but rather large ones. And here we're at the collapse, basically. We can collapse him, see? And we got the spectrum coming out of him. See those colored lines there? And that's really pretty cool because it's the only way that does that look at you like it's like playing a song. It's the harmonics perfectly coming out, and it's like a beautiful instrument being played in the heavens. Here you see the waves spinning. He's a slippery one. Here we got the waves spinning there. You can see them spinning. And see the answer now, or the calculator, is actually using light to calculate. That's where our input is for the calculator, and it's actually using light to make this. And my calculator doesn't calculate anything with light, but it's doing it right now. And I don't know how, or nobody knows why, but it's doing it, and it's making this hologram. And this pyramid of the ones does exist in nature, as you can see. It's spinning there and it's a wave. Um, and absolutely not having anything to do with the problem that I gave it to divide by. This isn't even really having interaction with the calculator. It's just doing its own thing. It's clearly a wave that was created. And it's made of X's and O's and doing all the things that we never imagined a wave could do, and making a hologram. He's making a projection hologram in this case, and he's projecting things outwards. And that should give you some idea of what's going on here. Of course, this is, again, harmonic series, palindromed and stretched out, even though it's very simplistic. Now, there are much more complicated waves. There are palindromes that go on forever. The harmonic series might not just be one harmonic series. It might be like 1 1 1 1 1 1 1, then 2 2 2 2 2 2 2, but all separated by zeros. And so it's like a 9-layer wave instead of these simple. Well, there are a few layers here. And if you look up here too, you can also see in here a lot of what he really looks like, clearer than what's down here in the animated part. There's a little bit better image up there. So what I want to show you now is the pyramid of ones when we calculate them. So this is what we get. Now this is the constant for the awareness. Okay, this is the number we were working with, 998. Turns out that you divide any number by this number, and it makes the perfect pyramid for you. Okay, and that's what we were doing. That's the first one we did. We saw the pyramids, but you can do it with any number. This is the CMB, but it's the inverse to the reciprocal to the CMB is 37. Of course, we take 37 divided by that number again, and it'll print out. It'll automatically calculate the entire pyramid for us to infinity. So now we know the expansion of that wave. It's going to go just like that. You can do it with any wave, and it's just like multiplying it by these one at a time. And you'd have to do that. That'd take you forever, but out to infinity. But you can just use this guy and this little equation here, and you can make the pyramid for anyone. And a pyramid is what everything in the universe is propagating on. Now, this becomes really important if you look here. So we got the CMB. The 27 is representing the CMB. Okay. On the pyramid of ones, this is what happens. It's right after we go past number 1 and we go to the 11, the 297, 27, the CMB times 297 equals, times 11 equals 297, which is the speed of light, 2997. So what we're doing here is we're building up the harmonic speed of light. It's actually the expansion of light. Calling it the speed of light is wrong because it doesn't go one direction. It expands 360 degrees. So you can see what we're doing with the harmonic pyramid is what it does with everything. It's expanding the speed of light, it's stretching it out, and it's palindroming it. And this particular speed of light, or any of these, work beautiful within the entire system. As a matter of fact, you can't solve the universe with any other speed of light. This is the correct one, and it will solve all your math. Everything will work out perfectly. And this is how all the waves in our universe all the important waves, the principal waves, are made, and how they grow and how they expand. They're all doing it on this pyramid of ones, every one of them, which is a major discovery. So you have some idea of what's going on. Now, we know the pyramid of ones isn't just pretend. You really saw it. It really can be created as a wave. We really did it. So that's it for this section of the math. Now, that's just a brief explanation. You have to go see the paper in the links. All the math is explained thoroughly in my paper called The Pilot Wave. It's discovered. And various papers that I have published. I'll put all the links down there. But all the math is explained. But the neat thing about this is that's it. We don't have to do the math. The math is all done for us by the waves. All we got to do is look at them and say, hey, look what's going on here. There's number iteration. Look what's going on here. There's harmonic series. We just look at it because we couldn't do it anyways. We had no idea that it was possible. There are some other things in the math department that are seriously lacking. They're great errors, such as the reciprocal to the speed of light, which is 33667. One of the most important numbers, constants that we'll ever have, and it's gone completely undiscovered until now. It's this number here, 33667. Super important because for every action there's an equal and opposite reaction, and light has a reaction, and that's it. And this is the collapse frequency, which has also got completely undiscovered until now. Very important constants in our universe. Really can't do anything without them. So there's a lot of discovery to be done still in this realm. But finally got our foot in the door. We know now who's creating reality. It's the waves. Through awareness, literally through awareness, creates a wave, and this wave of awareness is literally creating our reality for us. And we're part of this wave. We are part of the awareness. Um, so we get to create reality with it once you figure out what's really going on. But you only get to do that through knowledge. You have to be smart enough to create reality, which means you have to actually learn this stuff. And it's not hard to do. What you just went through is that's all the math. The rest of the stuff is just the same thing. It's just the pilot wave stretching and palindroming and harmonic series everything for you. Um, you don't have to do it. It's pretty easy once you get the hang of it. It's a completely different math system than anything we've ever had before, but it's a math system that works because it's discovered in the waves. Nothing in my theories is invented or theorized. Everything is discovered, and once I've discovered and confirmed it, then it goes into the paper. Not before then. Get rid of your imaginary numbers. Get rid of your trigonometry. Get rid of your calculus. Get rid of all that never did anything. That never solved a damn thing for us, and that's the truth. Because they're all invented math, trying to explain, trying to change the universe to fit their theories. And remember, the universe is never wrong. If your theory doesn't work for every aspect of the universe, then your theory is wrong, not the universe. You don't invent things to make it right. So that's it for now, and have a good day, and thanks for watching.